Hi, this is Miss G. So we're going to talk about specific heat capacity. So which do you think will keep you warmer, water or iron? So actually water, remember, I don't know if you're familiar with water beds, but that'll hold the heat, has a higher specific heat capacity. Iron loses heat right away. So specific heat capacity, the actual definition is the amount of energy required to change the temperature of 1 gram of a substance by 1 Celsius degree. So the equation we say is Q is equal to mCp delta T. Delta T is that change in temperature. So Q is the heat absorbed or released in joules or calories. M is going to be our mass in grams. Cp is our specific heat capacity. It has units of joules per grams degree C or calories per grams degree C. So you're going to look for that in the problem. And then delta T is going to be your change in temperature in degrees Celsius. So these are CPs that you should be aware of. Just be careful. You do need to know the CP of water, which is equal to 1 calorie per grams degree C. All right, so what change of energy in joules is required to heat 12.5 grams of water from 25.0 degrees C to 47.5 degrees C? So we know that Q is equal to M Cp delta T. So we can actually plug it in. We have 12.5 grams times our Cp, which is 4.18 joules per grams degree C. And then we're going to figure out our delta T, which is our change in temperature. So we have 47.5, that's our final, minus 25.0. So that equals 22.5. So if I multiply that across, we get 1175. I'm going to put it up here. 1175.625. That's joules. If I wanted, I'm going to do 3 significant figures with this. It would be 1180 joules. And that's your answer right there. What is the mass of a sample of copper? So when we're looking at things, this tells me that joules per grams degree C tells me that's Cp. It needs 20.5 joules of energy to be heated from 22.5 degrees C to 52.1 degrees C. So we have Q is equal to M Cp delta T. So this is going to be our Cp. This is our Q because it's just in units of joules. And then we can figure out our delta T, which is T final minus T initial. So that equals 29.6 degrees C. So now I'm ready to plug it in. So we're going to put 20.5 for Q. That's joules. And then equal to M. M is going to be our unknown times 0.385 joules grams degree C times 29.6. can multiply 29.6. So when we're solving this, we're solving for m. So basically, it's, we're going to do 0.385 times 29.6. So I would wait to the very end to round. So 11, I'm just doing this in case you're not sure about the math, equal to 20.5. So I'm going to divide both sides by 11.396, 11.396. So you end up with m equal to 1.7988. So if I round it up and I want three significant figures, it would be 1.80 grams. And that's our answer right there. So what is specific heat capacity in joules per grams degree C of an unknown metal weighing 5.49 grams that releases 42.5 joules of energy as it is cooled from 89.2 degrees C to 37.4 degrees C? So when it says released, this is my Q, that means it's negative, okay? So we know that Q is equal to M dP delta T. So this is our M, that's our Q, it's going to be negative, and our delta T is actually going to be negative because you're going T final minus T initial. So our T final is 37.4 minus 89.2. So minus 51.8. So we can plug it in. So we're going to do negative 42.5 equal to 5.49 times CP times the negative 51.8. So if I solve for CP, we're going to do 42.5 divided by parentheses 5.49 times 51.8. So the deal is we have negatives on both sides, so that actually goes away. So CP is equal to 0.149 joules per grams degree C. And that's our answer. So what is the net temperature change of a 3.8 gram sample, that's our M, of lithium, CP equals 3.582 joules per grams degree C, that absorbs 125 joules of energy. So that's our Q. So we're looking for delta T here. So Q is equal to M CP delta T. So we're going to plug things in. We got 125 joules equal to 3.8 grams times 3.582 joules per grams degree C times your delta T. So when we solve for delta T, we're going to take 125 divided by parentheses 3.8 times 3.582 close parentheses equal. So our delta T is equal to 9.18 degrees C. How many calories are required to raise the temperature of 105 grams of water from 30 to 70 degrees C? So Q, again, is equal to M, CP, delta T. This is our M, and our delta t, we're going to figure it out. So delta t is equal to 70 minus 30 to 40.0 degrees C. So the deal is, it doesn't state what your CP is, but if you remember from the beginning, our CP of in calories is this one. So that is actually the one that you need to know. So it's calories per grams degrees C. So I can plug it in. So Q is equal to 105 grams times 1 times 3. All right, so we put that in our calculators. And we get 4,200. So if I was going to do significant figures, 2, 3, so I would do 4.20 times 10 to the third calories. I wanted to get it to 3 significant